Number 4. For each of the 4 schoolhouses at his school, Lee is analysing the points scored in the sports competition. Using statistical software, he produced the 3 diagrams below. What we see here is some sort of line graph, a bar chart at the bottom, and we have a pie chart on the right here. A tells us to explain why diagram A is not appropriate for the data. Let's look at the data we've actually got. We've got some names, which are the house names, and we've probably got some sort of points system. So the points are here, and then the names are here for each respective graph. Now, why doesn't it work for graph A or diagram A? Diagram A you need to identify as a type of line graph. Now, from what I can recall, the only type of graphs that look like this is either a time series, a scatter diagram, or a line graph. And it can't even be a scatter diagram because it just doesn't work here. So what we need to identify is that the house names are not numerical data, so they can't be used. Lee wants to show clearly the proportion of the total points scored by each house. Explain which of B or C is the best diagram for Lee to use and why. Instantly, which one makes you think proportions? Well, it's obviously going to be the pie chart. The pie chart is literally a circle which represents the whole total, the whole, and from that you have your slices which represent the proportions. And the idea is that the pie chart shows a fraction of the total for each slice, therefore that's going to be the most appropriate one. And that's question 4 done. Question 5. Richard wants to find an estimate for the number of rabbits living in a section of woodland. He caught a sample of 25 rabbits, attached a tag to each rabbit, and then released the 25 rabbits back into the same section of woodland. 4 weeks later, Richard returned to the same section of woodland and caught a sample of 10 rabbits. 2 of these samples were tagged. Using the results, Richard estimated that there are 125 rabbits in this section of woodland. Show how Richard worked out his estimate of 125 rabbits. Now, there's a couple of words that instantly make me think about the topic, which, if you haven't noticed yet, is capture-recapture. The first of which is tag and caught and things like this. Now, they typically use capture, caught, tag, and basically the format is always the same. It's always something like 1 week later or 4 weeks later, and they return and take another sample. And basically you should identify that this is capture-recapture. Now, I've got a video on this and I've illustrated how to answer these type of questions. So if you're not familiar, I would recommend you watch that now. But if you are, then have a go at this and see if you get this. So the formula I use, and there are plenty of methods to go about, however I'm going to use the method I'm most comfortable with, is just to use the formula, which is uppercase M over uppercase N is equal to lowercase m over lowercase n. Now, in respect to each of the letters, I'm going to spend a bit of time labeling what they mean. The capital N here is the total. Here, that's what we're actually trying to estimate. We're trying to estimate the total population of whatever we're looking at. Uppercase M demonstrates the number in our original sample, or the first sample. Lowercase n, on the other hand, represents the number of our second sample. And lowercase m shows how much of that second sample were originally tagged. Now, this is all clutter, so I'm going to make them disappear. Now, Edexcel's actually been nice this time, and they've told us the number that we're trying to get to, 125. And you basically need to read between the lines and see what you want. An estimate of the 125 rabbits, well, that's got to be the total number of rabbits in the woodland. So, for that reason, we're going to try and find capital N. Now we need to identify the values which correspond to the letters of the formula. So as we saw that capital M was the number of our first sample, let's find that value here. He caught a sample of 25 rabbits initially, and then he attached a tag to each rabbit. So capital M becomes 25. And we don't know n, and we're trying to find this, so we'll leave it as a variable. Now we need to try and find lowercase n. This is the number of the second sample. And we can see here, 4 weeks later, Richard returned to the same section, and he caught a second sample of 10 rabbits. See what I mean by reading between the lines, because it doesn't say second sample, but you need to interpret it as he returns. That means it's going to be the second sample. So our lowercase n is going to be 10. And then our lowercase m. Now lowercase m is the number in our second sample that was originally tagged, and that number here is 2. So now all we need to do is simply rearrange for n. Now if you're strong at your algebra skills, then you can do this quite easily. If you're not, watch my video on rearranging equations, which should help you in a way that you can feel comfortable with answering these type of questions. So I'm going to cross multiply, and if I multiply both sides by n, I get 25 equals 2n over 10. If I now multiply both sides by 10, I get 250 equals 2n. And then if I do this, and now I divide n by 2, you get n is equal to 125. And you can type this into your calculator to verify it. And that is part A done. By considering Rich's statistical method, discuss the reliability of his estimate. Well, let's actually take a look at what he's actually done. He's caught a sample of 25 rabbits with no mention of how he's done it, and 4 weeks later he returns. Now that's a key part there. And the tags, he uses tags, and this is a big one, and I highlight it in a video. This is just such a common pitfall of this method. The tags could fall off, and I'm going to use that. So we've seen that he comes back 4 weeks later. Well, in 4 weeks, a lot of rabbits can be born and a lot of rabbits can die. It's as simple as that. So that's going to skew his results either way, and he can't tell if they've died or if they've been born, so he can't really adjust his number for that. So what I'm going to say is that it's unreliable, which should be 1 mark, and then we're going to have to give 2 supporting reasons, as it's 3 marks. And basically what I'm going to say is that, well, the tags may have fallen off, and there's been a long time between the samples. Now, you could also put that it's a small sample, and that is true. He only caught 25 rabbits for the first one, and 10 rabbits for the second one, and somehow has come to a conclusion of 125. It's not statistically reliable in the sense that it's going to be 100% accurate, and a small sample size doesn't help. You could also say that the sample's not random, and I said this, he caught a sample of 25 rabbits with no specification of how he did it. And the rabbits may have not been mixed between the samples, and that is a key part of the method. You must mix the rabbits thoroughly with the existing population to ensure it's not biased. And yeah, that's basically it. For 5 marks, this question wasn't too bad. Question 6. Barbara found the following information about the average gross pay in euros for males and for females in 10 countries in 2010. So the countries and males and females and all that is listed here. Barbara investigates this information using a suitable graph. Using the information in the table and her graph, she reaches the following conclusion. There is strong evidence that for every €10,000 increase in gross pay for males, gross pay for females increases by €8,000. Okay, so that's just the question. So let's look at let's look at part A. Explain, giving reasons, what Barbara is most likely to have done to reach these conclusions. We should consider which type of graph she will have used and why, how she will have used the graph and the information in this table. So the first thing we need to do is go back to the table. It says that using the information in the table and her graph, she reaches the conclusion, and she investigates this information using a suitable graph. So by using the word investigates and this information, it suggests that she's using the table in her graph, or the table formulates her graph, and then she's using the graph to actually investigate and analyze. So the question asks what type of graph she would have used and why. So what diagram can we actually use here? Well, the moment you realize that the countries are just points on the graph rather than having any relevance to this question, you understand that it becomes male versus female. And that is the whole point. She's concluding that males receive more pay than females. So there's no mention of countries, and we can just get that out of the way. And that leaves us with just two variables. Now, two variables means one thing, and that is bivariate data. The next thing we need to do to narrow it down is look at the type of data. Are we looking at continuous data or discrete? And you can see here that all the data is discrete. It's not continuous, so it couldn't be a time series or anything, even though there is no time value here. I'm just illustrating that. And now we've got two conditions, bivariate data and it's discrete. And what comes out to me is a scatter diagram. So what she could have used, or what type she would have used, is a scatter diagram. And the reason for this, because we need to give so, is that the data is bivariate. So now we've used this line here, or this bullet point, we need to focus on the next bullet point. How will she have used the graph and the information of the table? Well, let's focus on the information of the table first. We can kind of gather from this is that she's using her data in the table and, well, her hypothesis or a conclusion, and she's basically putting it into the graph, and we've already discussed that this is a scatter diagram. So when you're using a scatter diagram, and a quick illustration here, you plot your points, and what do you do with them? You join them, and what do you join them with? A line of best fit. Now, the line of best fit usually does two things. Well, it's got two components, and that is the gradient that you need to be mindful of, and also it needs to go through the double mean point, and we saw this in an earlier question in the video. And the double mean point is the average of all the x and y values. So it needs to go through that double mean point, and it has to have a gradient. So what's the gradient here? And you need to be careful not to mess it up or mix it up. And you need to be careful not to mix it up with this product moment correlation coefficient. Although it might seem similar, it's actually going to be that for every 10,000 increase in males pay, 8,000 increases in female pay. Now, before we move on to the gradient, we're going to have to identify which axis is for the males and which axis is for the females. So basically, the independent variable always goes on the x-axis, correct? So the independent variable is the one we're changing, or the one that we control. And the idea is that we're controlling what the pay was for the males, which was 10,000, and we were seeing what the response was in what the dependent variable was, and that was for females. So the females would go on the y-axis, and the males would go on the x-axis. And the idea is because we know what the pay for the males was, we're looking at how the females differs from that or responds to that. And therefore, for every 10,000 increase for males, we were going to have an 8,000 increase in females. And then you can just do your change in y, change in x, and you'd get 0.8 as your gradient. So what you need to identify for your next two marks is the double mean point and the gradient. And you need to be able to distinguish the gradient from the PMCC. The PMCC, however, we're going to use that after this. So let's just quickly write that down. And the gradient here tells us the relative rates of the change in gross pay. For example, how the change in females with respect to the change in men's pay. Okay, so now we've got 4 marks worth, and the question was 5 marks. So the idea is when you see a 5-mark question, you need to think about how it's asking you to lay out your work, and here it's giving you 2 major bullet points. You want to split your marks roughly half and half, and here was 3 marks for the latter. Now obviously it wasn't that easy to tell which one needed 2 marks and which one needed 3 marks. But you could kind of see the quantity of information they've given you. And to be honest, I just answer the question right there and then as fast as I can and as accurately as I can, and then see where the marks are coming from and see if I've missed anything from each of the bullet points. And the last one is the PMCC. We haven't spoken about that yet in detail. The PMCC basically shows how close the points are to a line. So this and this, they could have the same PMCC. Just because the gradient's different, the PMCC isn't to be confused with the gradient, which sometimes I feel it is. And the PMCC is a high value because the PMCC can be any value between -1 and 1. And because it's much more closer to 1, because it's roughly 0.83 something, 832 I think, well, it's going to be quite strong correlation. And this strong correlation means her evidence is strong, because as it goes up by that amount, it does go up by that X amount. And therefore, the evidence for her is strong. Explain why Barbara's conclusion, based on the data in the table, may be unreliable. And this is 1 mark. So I'm coming back to the question, and instantly you can see it's in 2010. Now, we're in 2026 at the time recording. This is 16 years ago. So one easy thing I can write, this is old data or it's out of date. Now, what could you also put? Well, you could put as a small sample, and we saw it here. There's roughly 10. Yeah, there's 10 countries, not that many countries, and for each of the countries, there's only one representative male and female, which is not accurate at all. And another point you could put is that it's secondary data, and that's true. It says here that she found the data. She didn't collect the data herself, she probably found it from an external source, maybe the internet. And it could be affected by varying exchange rates. To be fair, I wouldn't have thought that last point in the mark scheme. That's quite of a niche one. Anyways, that's question 6 complete.